Thank you, Katerina. And thank you for bootstrapping this consortium too and bringing some of the projects together. It's helpful. All right, so let's get going. I got a lot to cover. So just a kind of quick background on Fishial. It's being funded by the Y Foundation. It's a family foundation. We kicked this project off in 2019, basically as a moonshot project for educational conservation efforts. Initial work was performed by the Fish Angler sports fishing app, which uses it today and contributes a lot of photos basically into the project. Initially kicked off at a $250,000 seed funding. That's been increased to about $1 million. We have 10 full-time people working on the project, biologists and about 9 full-time labelers that label images. And we also basically review all species that have been labeled. And so it's a big data project, a lot of work to get that done. And then also the code development, which is still active on the project. It's a group out of Poland called Code Ahead. We have 5 developers that work on a weekly basis. So our mission, basically is we're seeking the development of a highly accurate open source AI model that can be identify fish species anywhere in the world. So when I said it was a moonshot project, it truly is. And I'll kind of demonstrate why in a minute. But what our goals are as a project is, again, to create that highly accurate open source AI model that can identify the species. So when I say identify the species, identifying the actual scientific name of the species initially, eventually getting into can we identify a unique species within that group of species. The first goal, just doing classification of the species, is a big enough project worldwide to run us the next 20, 30 years in trying to accomplish that. So as I get into some of the numbers, you'll see why. We decided to build an image content management system. So some of our funding went into building out an infrastructure that we could use that's auditable, that is reviewable on actually the data that we collect. And then we're also looking to, as scientists and researchers, create different data sets. We want to be able to roll that into one larger data set that's been QA'd and then give that back out as an open source data set. So you'll see a little of that in the next couple of slides. So the reason why I say this is a moonshot is we're not looking at a set of 10 species that we want to identify. We're looking at the whole world of, it's debatable the number of species. It's, say it's 33,000 species out there. Depends on who you talk to. Maybe it's 20,000, maybe it's 40,000. But the idea here is that the data set, in order to make it work worldwide, for reef fish, for aquarium fish, for recreational fish, for deep sea fish, it's a huge data problem. And so this slide's just to iterate, if you were to collect 1,000 photos per species, we're talking 33 million photos. And if you take a look at the manpower required to actually label those and verify that you have the right species, basically it adds up. A single person here as a quick, you take it 6,610 years to have one person work 8 hours a day and actually be able to do 33 million photos. It's a huge project. So we decided to try to use technology to make this effort as quick as possible. And that's what we're focused on, is how can we collect the data, analyze it, label it, and produce data sets that people can use in a reasonable amount of time. So what we're doing to accomplish this whole goal is fish identification model is a model that's pre-built. It's out on GitHub, and I'll go through that in a second. We've put a lot of effort into this image management portal. From that, we've built a developer's API where if a project wants to use an API to do fish identification, they can go ahead and do that. If they contribute those photos back to the project, access to that is free. And then basically label data sets. So today we work with a couple of different organizations to give them access to data. We haven't published an open source data set just yet, but that's our overall plan. Moving on, the fish identification model. It's out on GitHub. You can basically look at it out here. We first published this over 4 years ago. The training scripts are out here. There's a demo link to basically an application that we have out on the website where you can go and, let's pick a species here, upload the photograph, and it'll analyze what's in the photograph. If it has a match, it'll give you, so it's segmented this. It hasn't done it perfectly. The tail part is somewhat chopped, but it's gone out and matched this as a great barracuda. That's a quick demo of the actual model. The classification or the segmentation side of this is we've built a fairly accurate polygon-based, there's some people call them polylines, basically to find all the fish in the picture and draw a polygon around each one of it. It will automatically identify the species if it's known. If it isn't known, then it takes manual intervention. Right now, we can do about 289 unique species. A lot of those are in the recreational sports fishing area. Moving on, our image management system. So this is basically where we've gone and looked to optimize the receiving of data, labeling that data, and putting a review process in place. So a biologist is always looking at the final product, meaning each image, and accepting that image as they believe it's the right species. So this is, we call the IMS. It does image collection. It allows you to have an individual collection of photos for a user. This is a free product that we provide for collaborators. It has a team collection capability. So if you have a team of individuals that are going to do labeling of a data set, you can import the data set into a team collection, and then those individuals can all join the team and work on that team. We have what's called official collection. Is once images are collected by a user in a team and they want to submit them to the official collection, they go into a pending state, and I'll demonstrate that in a little bit, but they get reviewed by a biologist in the end before they're accepted into the model. There's advanced search capability within the portal, so you can find all the images that we support. A lot of metadata on every photo, anywhere from GPS location to looking at an image, copyright information, height, width, weight, length, various attributes, if the by gender, etc., of a species. The next couple of slides will go into that a little more detail. Exporting data sets, we can export them in Cocoa. So it's Microsoft's Cocoa format that's pretty popular, and there's converters to convert that into other formats. So the upload process, basically, I just demonstrated previously that you can upload a photograph, it'll automatically segment it, and then we have the ability to drag and drop a photo in. You can batch load them from a CSV file, and then we have a developer's API to contribute photos into the collection. We automatically segment and classify if we can. We have face blurring technology that can be turned on or off, so for privacy. And then on a individual image basis, we can do copyright. So if I jump into the portal here quickly and I take a look at some photos, say if I edit this photo here, and we have a built-in database of 33,000 photo of scientific names and thumbnail images. So we can relabel things, we can rescan things. At this level here, with this particular fish, we built in the capability to actually label all the morphological features of the fish. The AI model that we're using today is not using this currently, but we believe in the future, we're going to have to actually start to look at different attributes of the fish over and above what a standard RCN, neural network's doing. And maybe we're going to look at pattern, color pattern, or markings and so on. So this has been kind of pre-built for that. You can declare, the sex of the fish, the age, is it spawning, was it dead or mutilated? We also work on, it may be in a fish market, a fillet, the height, weight, girth, etc. So there's a bunch of metadata both at the image level. At the image level, we can support X-ray images. We have various test data in here too that you can mark images, test. Under copyright, you can basically have a license per image, basically. So we have a lot of photographers that will contribute their data set to the project, but they don't want them distributed. So we use photos from a lot of different sources. We use iNaturalist, and we pull over the copyright that iNaturalist has, Creative Commons. So depending if you're working on a commercial project or a non-commercial project, you can mix and match data basically. Let me jump back to flip to the next. So fish labeling. Again, I kind of went through this a little in the previous slide, but you can head shape, eyes, body pattern. There's about 10 or 12 different attributes, morphological attributes about the actual species you can go ahead and target in label, and then other metadata. Once a user or a team has gone through and labeled the actual fish picture, where we support more than one fish in a picture, by the way, you could have a picture with 10 fish in it, and each one will have its individual metadata. So we'll take at the image level, break out 10 polygons, and each polygon represents the fish that's in the picture. Once you go ahead and do that, you can go ahead and submit it. It goes into a pending review. So this is kind of the submittal side. We have these user collections and team collections that go into a pending state. Once a user has submitted it, it gets a biologist review, and then it goes into a verified state within the project. And then once it's in a verified state, it can be used in building the overall AI model. We also have extended the verified state to being able to have multiple people QA the same photograph, and they have to agree to the actual species. So there's a set within the portal for QAing review tools. So this is an example of looking at a particular species. You can agree that it's the right species. You can say, no, it's a real poor quality photo, or it's something, it's suspicious. You can't really tell what the species is. There's not enough in the photo, so you can flag a photo. ODM review is our segmentation model. So out of the total images that we have in the system, a segment of those that qualify go into the ODM review data set, and that's what's used to build a segmentation model. The classification model that we have is more lenient on, you can have obstructions, you can have hands, fingers, etc. In the picture, and it still can be used in the classification side of things. Moving on from the portal into the developer's API. So basically, we have a RESTful API. You get a developer's key through the portal. You can then authenticate. You can upload a photograph, and then you can perform fish identification on it. And that API, we provide over 5,000 fish species thumbnails. So if you're displaying the data back on your app or website, you can use the thumbnails. There's documentation for that. There's like a tutorial out here, step by step, on taking a photo, being able to properly call the endpoint, and go ahead and launch the actual service. Coming soon, in next couple of months, we're going to come out with a widget that can be given out to fish and game or educational sites for fish identification. We're going to kind of target mainly recreational fishers and some dive sites with this. And it's basically an educational tool to allow someone to perform fish identification embedded in their website. Another thing that we're working on, which we can get into a little more, is we're working on a benchmark data set. So there's a couple of projects that are working on fish identification. And what I like to do is kind of, through the consortium here, see if we can get other groups to take the segments of fish that they're working on and contribute to a testing/benchmark data set. And we're building one internally today. It has about 100 unique species in it with more than 50 images, and another 300 unique species with less than 50 images in it. And what we're planning to do is basically, as we grow the number of species that we can put into our model, we have the requirement of being able to benchmark the old AI, an older AI model to the newer AI model, and based on things that we focused in on, we want to look at how well did it perform. Is it truly as good as the previous model that we had put out? And yeah, there's mechanisms to do this in standard machine learning to an extent, but we want to have more of a track record to be able to take an independent set of images that would never be put into the AI model, contribute it back to the consortium, see if we can get some other companies or organizations to contribute and build that up and make it available to everybody in the consortium. So moving on here, labeled image data sets. So basically, the copyright that we support on an image level, we will put out a non-commercial, commercial, or non-commercial data set. The whole area of AI is getting sticky about copyrights in what source. Early on, this wasn't a consideration. When ImageNet came out, they had a concern, and they used URLs to point out to the photo and so on, and that became a mess as things got broken links and so on. And they had an internal copy that if you're a researcher, you could get the actual image directly from them. So we took a similar situation where we want to control that we have a copy of the image, because we're going to put manpower into it to make sure the bounding box polygon is accurate and the species labeling is accurate. So basically, that's where the copyright comes in, and we anticipate to put out multiple image sets. The first one that will go out this year will be the testing benchmark one. The other two variations will probably come out with like an iNaturalist data set, since that's not with the same copyrights that they have had on from their contributors. And then depending on the project and how we can distribute those images, we'll have additional images that go out in those data sets. A lot of what's holding doing this today is really manpower to be able to look at enough images, make sure that what we put out there is useful. And we are giving some early access to a couple of different groups and getting feedback and so on, but it's a massive project in manpower to do this. Some of our partners, as well as some of the mobile apps and web projects that are currently doing, Louisiana tagging program, Fish Angler is contributing about 5,000 images a day. Catch and Fish Buddy are just coming on. Angler's Almanac is a fish identification tagging app, and basically contributing photos, and we're contributing back fish identification. Some of our future plans, the biggest thing is we've spent a lot of time and money to put together an infrastructure, and in order to make this fulfill the dream of actually doing this on a worldwide level, is we need to collaborate with a lot of projects worldwide and have them contribute data back into the project, which is key. So today, if you're willing to contribute those photos back into the project, we give you basically free access both to the portal, to the developer's API, and other things, as well as the ability to export your own data set from a team or individual. So in order to make this free, we would like to get a contribution of data back into the bigger model. That's pretty much how our model has been set up to try to get this to explode across thousands and thousands of species. The key here too in building out an AI model is you need enough images. It's fairly easy in the recreational space because people are taking pictures of their catches. So there's a core set of say 2,000 different species that you can get data pretty quickly. Reef fish we're starting to try to work with a couple of reef.org and so on to try to get surveys, photos from surveyors to get pictures of reef fish. And then we're working with divers also to get images from the diving community. So future plans here is really collaboration is our biggest one. Build out the benchmark data set, go ahead and release open source image data sets. And then ultimately, a personal goal of mine on this project too, from an educational point of view, is create a free mobile app that you can walk through in an aquarium and be able to identify the species you're looking at in the aquarium. So that's one of the things that, as we get to critical mass, we'll go ahead and build that. How can you support us or support the consortium? We've built an infrastructure that can be used by the consortium and its members. We'd like everybody to contribute, basically. And so the hardest part of the project, once you get the data into the project, is validating that it's truly the right species. And again, local knowledge is good. Getting folks that can contribute from a technical point of view, from a ichthyologist point of view, that's basically a big challenge. We have money set aside to be able to hire folks, and we're looking to hire some more biologists to help in this project. But It is very time consuming, going through each photograph. And so, um, the instance of like iNaturalist, you can download photos from iNaturalist that have a research grade, but it doesn't mean it's actually correct, even though two people said it was. Um, the data is really subject to errors, and we're trying to close that hole with this project. I know VIMS, up in Virginia is in the same situation where they're trying to, make sure the data that goes into their model is accurate, so they don't get errors coming out. Websites, Fishial.AI, we have a website out here, Fishial.AI, that you can go check out. The portal that we showed earlier, there's documentation for this project. You can go check out user guides, tutorials, etc. There's basically the fish identification, is out on GitHub. So the models are down towards the bottom. There's various links. This is the latest classification model here. You can download it. You can run it on your desktop, put it out in the cloud. And then this is the link to our demo, which I had showed you, where you can actually go ahead and upload. But that's kind of what I wanted to get through, at least on the front end. I'll take some questions now, and then I'll jump into a quick overview of the AI model itself. Questions?
Thanks, Tom. That's a really huge project and very useful resource. Yeah, you can please go ahead and unmute yourself.
Okay.
Yeah,
All right.
Yeah.
So on the AI,
so hi. Oh,
good.
So hi, Thomas. Thanks so much for your presentation. Really interesting stuff. I worked with the IGFA on their fish identification app almost 16 years ago, and things have come so far since then. So really great to see this progress. I'm curious about the kind of historic resistance in a lot of the recreational fishing community to sharing location, which is, automatically included in your Excel files off your phone pictures, unless you strip it. And so you're giving people an active option to strip the location. And I'm curious if you're seeing more people being comfortable sharing their location, or are lots of people stripping location data out? That location data can be really valuable once it's shared with managers, but you have to have, as you know, like a lot of data points to make it valuable. So I'm just curious if that location angle is a feature or a barrier, or if people have just changed and it's not as much of a concern anymore.
It depends on the person, obviously. So the other project that I'm the CEO of and the founder is a mobile app called Fish Angler. And this project was originally within Fish Angler, and I kind of said, no, I'm going to move this out into a nonprofit and give back the technology side of this. And Fish Angler has about 3.5 million users around the world, and 95% of them have location services on their phone, and they log the actual catch location. So we'll get, basically, on an average day, we're getting 5,000 or so images that are sent into Fishial from Fish Angler. And most of those images do have catch locations. Users aren't as sensitive. Certainly some of them are. The better the angler is, we find they're more willing to share a location. They want to educate people. And there's certainly let's say the group of the 5% that contribute to the platform that don't want their location shared. They don't want folks to come into their spot, and I completely understand that. It depends on the fish that you're targeting and where you are and so on. But I think from a I'd like to also follow up with you too, because Fish Angler has a relationship with IGFA also. Do you still work for the IGFA, by the way?
Oh no, that was that was a while ago, but I'm happy to follow up with you. I can put my info in
Okay,
the chat.
sure. They have mentioned that project in the past, and basically, ultimately, we'd like to be able to contribute back for the IGFA too, to be able to identify. They track about 1,800 worldwide records or species. So, I think the bottom line is data can be anonymized where you don't know the user, but you basically, there's another project out there called FishBrain that has done this also for researchers, and Fish Angler is willing to do that at some level, and there's, I think, Anglers Atlas has done it to some degree too. So it's certainly possible if you follow up with me and we can discuss it. Other questions?
Hi, Thomas. Thank you so much for your talk. It's really interesting. So I have a quick question. It seems to me that through Fish Angler, you're able to ingest quite a lot of data daily into the platform. And that makes me think that obviously the data distribution between underwater pictures and above water pictures might be different. So I wanted to ask you, is there a difference in the performance of official models for pictures taken above the water and under the water?
I don't have good say scientific data to point one way or another. We do mix. So one of the requirements for the AI model today is that if a human cannot identify the species in the photo, AI probably won't be able to either. So certainly underwater photos, you could be murky water, dark water, they're blurry, they may not be able to be clear enough. At this point in time, we have a distribution. Yeah, it's heavy on above water photos, but there's a lot of underwater photos that are also included in the data set that we're using. So through iNaturalist, we pull a lot of photos in that are underwater. We have divers that are contributing. We also do have metadata that marks a photo being taken underwater or above water. So we can, if we find an issue, like we want to do a pure recreational above water type of model, we could export only pictures above water, or if you want to do a diver's one, only below water. So today they're mixed, and I would say it's 75-25% off the top of my head on mixture of above and below water. But
I
the
see.
common theme is you need to be able to identify that species. Murky pictures, bring down your accuracy, obviously, from what we've seen. There's no AI can only get you so far. It can give you an educated guess, and we do have the capability of saying, hey, it could be one of these 5 species that the model understands, and here's the probability of each species being it, and it could be completely wrong in that situation. So every image that's sent in for identification, depending on how clear the image is of the fish, will come back with a different probability of a match.
I see. Thank you.
Yep. Okay, I'm going to move forward with this. So in looking at such, potentially, 33 million to 100 million images that you need if you're going to go for all species. We looked at, okay, how can we ingest data quickly? How can we segment the species? And I think I've demonstrated that today. From an AI side of things, these were 3 traditional methods. what
Tom,
we,
sorry, Tom, can I just interrupt you and ask you to share the full screen?
oh,
It's
okay,
in the presenter's view. Yeah, thank you.
sorry. How's that?
Yeah, that's perfect. Thank you.
Okay, so we took a look at the segmentation side of things, and I'll get into this quickly. Far as the segmentation model, this was some stats as of 10/2/2013. We're about to rerun this in the next week or so with probably about double the amount of data. But the training set itself, basically, we used 49,000 images that were hand drawn for the most part, or hand verified. And then another 14,000 for verification of the segmentation model, representing about 289 species, with a, we put a cap on 535 maximum images. Some species, we have thousands and thousands of labeled images, like largemouth bass, easy to get, easy to identify. But we basically, until the model gets bigger, we put a limit on the maximum and the minimum number of photos before that species goes into the project. So the segmentation side, it was these two tops. We used 59,000 images, 6,846 were validation, and then the classification. We spent a lot the last 3 to 4 months in looking at, out of the current 289 species, we wanted to get a lot of those species up to the 500 image level, and that's been our big focus. The next model we put out will probably have about maybe 400 species that we can identify, with most of the species, probably say 50% of them, may have a 500 images each, and the rest of them will be from, probably 40 to 500 images that have been perfectly segmented, and then verified being the right species. Just a kind of a quick look at what the typical data looks like, some underwater, some above water. But we, to make up, say, that 500 images per species, we're mixing underwater and above water. We haven't gone to, say, all right, let's just do above or below. We're going to try to keep it mixed. So basically, this is your standard look at our segmentation. We use point rend. This gives you a kind of a quick demo of 224 by 224. You see in this picture here, the hand is completely shown. This has worked really well for us in building the segmentation side. Again, the idea is that we're trying to take any obstruction of the fish and mask it, and human verify the image that it's been masked correctly. So that model worked well. There's some tuning parameters out here on what we used, and then getting into the fish classification side. I'm not an AI guy per se. Our AI engineer was not available today. Most of our coding is done in Poland for this project. It's a completely independent project from Fish Angler. It's funded by the Y Foundation, but it's run by a company called Codahead in Poland. They also do the AI side of the project for us too. So they put together kind of a multi-layer classification model, and there's some information about that. We could get into that at a later date in more detail, and we can bring the engineer in to discuss this, but he put out some of the tuning parameters of the model and some 3D effect and clumping of images. There's some test data out here on different tuning parameters and then accuracy levels. Anyways, this is all out on GitHub. I will put this presentation out on GitHub also, so you can reference it. But any questions on this? Okay. So I guess the one question for the folks that are on the call today, and we've been talking here for a while about the consortium and how we can contribute and work as kind of a team on different things. We put a lot of effort into the front end, and we have a model that we use in the project itself. I'm kind of curious of the folks that are online today on what the thoughts are, especially in the benchmark side, as well as contributing, expertise in the AI side of things. Really good AI folks are very expensive these days. A lot of the best are working for Facebook, Google, etc., and they're getting paid millions of dollars a year, to do the work that they're doing. So one of the deals for us, we started this project looking to do the data sets and not get into the AI side and let researchers do that. And then we found that we needed to automate how we actually produce our data sets, and we started to do the AI side of it. Open question for folks on the call here is, frankly, what's your thoughts about contributing, data that you currently have or projects that you're currently working on back into a data set that this consortium actually puts out. Obviously, Fishial could be the infrastructure for that, but a separate data set could be created that can be distributed for members of the consortium or outside of the consortium. It's really a call to have multiple organizations work together. And I know, some of the friction that I've seen in some cases is organizations are trying to get their research paper out, and they don't want to release any of the data until their research paper, has been published. And the data that gets out typically when they do publish are very small images. There hasn't been a lot of sharing in the scientific community in this sense. We're looking to kind of break that, and I understand that there's needs to hold on to data until they are recognized for the work that's been done, but I'm kind of curious on the folks that are on the line, an open conversation about that, because that's the roadblock for everybody, I think, in this space, is that collection of data and the labeling of data is the hardest part and the most time consuming and the most expensive if you're going to do it accurately and scale it. Comments?
Hi, Thomas. Hi, good afternoon. So I'm not a AI guy. I'm a biologist, and I'm very interested in your talk and your products. So in my point of view, there's no conflict at all in sharing data for this purpose, because what I do with my data, it does not focus on this, but actually this is helpful. So I was just wondering if you are able to process video clips as well, or only still pictures, because most of my data is video, So
today it's strictly pictures, but there are some processes that are you know, available to take video and auto capture you know, pictures out of the video basically. So that's something that we have not focused in on. I don't know if anybody else in the consortium has, but I do know that there's some camera trap type of you know, projects that have been posted out on GitHub that would allow you to take video and cut it up into, you can actually even call your segmentation model, find the fish in the video and basically create a data set that way. So it's not something we've focused on, but it's possible to do.
Yeah, and then I have a follow-up question, is because in my reasoning, if you work with video clips, you actually will be getting thousands of pictures of the same fish in different positions, which will be helpful to train the algorithms, right?
To a degree, it is, but also it helps for unique species. So you could flood a model with the same fish from different angles. That's important, but at the same time, having, you know, 500 unique photos of the same species, but different is also very important because you have different lighting conditions. You have fish that, you know, if it's taken out of water, may change color. You know, there's a lot of, it depends on the angle of what you're looking to build. If you're only looking at, you know, is this a fish or not a fish? Not really an issue. But when you're looking at, you know, being able to do it in a diverse situation, there's a benefit of unique species of photos.
Okay, thank you.
Thank
Anyway,
you.
I'll be talking to Katerina for regarding data sharing because I want to participate for sure.
Okay, great. Appreciate it.
Mhm.
Hello.
Hello?
Taking the taking the lead without raising my hand. I'm a really bad student. So my name is Thomas too. I'm working in the Indian Ocean in La Réunion Island. We've been working with videos for quite a while now. Videos. So basically, we quantify community of fish using well, videos and counting fishes, and we have been using AI for a while. And as you know, like the big question is the big task is to get the data set to train the model. To your concern, like developing the model, to me, is not the key nowadays because you have Facebook, Google, and all those developing like crazy models that you cannot fight with. But yeah, the key is really the data set. The point that we experience in the past years, where if you do not train your algorithm with the kind of picture you actually have in the end. So basically, we put in cameras underwater at different depths without light. And so you end up with blue kind of fish. And then if you do not train this kind of picture in your algorithms, then you cannot detect them. And what we found is like, first is detecting the fish on the picture and then identifying work pretty well. But yeah, the key is to get all those pictures in the setup that's correct for your work. And so my question was, what kind of metadata do you keep with your picture? Like you say this picture was hand taken with flash. It was taken from a video from underwater. Is it taken? So because I think to be able to say, okay, I want to use just this sub data set to train the algorithm to later on actually be able to use this picture efficiently, that might be important. So that was just a simple question.
So the metadata that we're keeping, we don't necessarily keep attributes that we have ability to do a custom attribute, and we have ability to add new attributes to the metadata. But today it's typically, if it's underwater, it's the depth. Most of our photos don't have depth, but we created the capability for someone to actually at upload time or labeling time, they can specify, where it was taken. They can specify, different attributes about the species, if it's a spawning fish or, approximate age of the fish. We're also looking at adding some fish diseases and so on. So we can have a data set that basically is, can be used for a lot of different purposes. And you can, since it's all database driven, we can export what's required. One question I had for you on the underwater photos, have you ever tried to remove the coloration from the actual image? So like there's diving apps, for instance, that give you the ability to change the color, pretty much remove the coloration of the image and show you a more truer color of the fish based off of, it'll take I think it's Divers App Plus, has had this for years, and they look at the background color, and then they remove it, and they do a fair job at that. So you're taking out, some of that deviation, be it brown water, blue water, dark. If you've ever played with that capability to see if you could normalize the coloration.
Our bet is to focus computing power on actually treating the picture, treating the data, and not to transform the picture. And the other guess we have is depending on the sensor you use, and you actually lose those colors when you deep. You cannot add them up, like the reds, because we work up to like 80-meter deep, and so there is no more red, no more yellow, no more. It's just the blue that reaches. So transforming those picture, we didn't even went that road because we would transform the data basically, and bias the algorithm to detect. So it's a tricky one, the natural color and depending on the depth. So yeah, that's but probably we're wrong, and having more and more pictures is we all also, like, at first, I mean, I'm not an AI guy, I'm a biologist, and we collaborated with computer people that do the AI side. And at first we were just saying, oh, we need 2,000 pictures to train the algorithm. But if you're within standardized environments, then you can go lower in the number of picture per specimen. The point is, once you have something that is more or less works, then you can use this algorithm to extract picture. We didn't got there because we're just working with like a few amount of people, and us biologists who are really optimistic and really we want this to work, but then you need the money and the infrastructure to make it happen. And our dream is to identify automatically the fish, to measure them, to quantify the numbers on each picture. But the problem is like, yeah, I think as you say, we need to work together, otherwise it's never gonna work.
Yep. Yeah, Microsoft has also done some work underwater too. They had a project with in Australia in the Darwin area to use underwater photography through CCTV cameras. And there's I don't know if there's a project on GitHub that they published that work. You may want to take a look at that too. We talked to them a number of years ago when they were, I don't think they got some funding, went to about 50 species, and then I'm not sure if they're continuing to expand it, but it was strictly focused at underwater, video and doing it in real time because of saltwater crocodiles up there, I guess. Other questions? Yeah.
Our tech is to in dangerous places put robots and cameras down there rather than actually go and take picture. That's also Andy part of this.
Thank you.
Hi, Thomas. So just wanted to pick up your previous question about data sharing. I'm an AI researcher focusing on ocean conservation, and so I mainly work with marine biologists that have data sets, then train an algorithm, a bit like Thomas mentioned, fine-tuned algorithm for specific locations or species, for example. And to me, it is quite interesting to share data, mainly because 90% of my development work is not AI, it's just data management, data annotation, and everything. And as you say that you are focusing a lot on the data side rather than on the AI side, it would be interesting for me just offset that in an exchange of the data and just focus on the AI. And it's also interesting when what you mentioned about you having a rigorous workflow to verify the image and assign the classification, because that's also a bottleneck of generating label data set. So I think it would be interesting, this kind of collaboration where AI researchers like me that have access, first-hand access to datasets, can share the data in an exchange of a data management platform and biologists that annotate that data. One only concern that I have is that sometimes when you work with organizations, they do not want to share the data. And so as a researcher collaborating with them, you can develop algorithms on the data, but you can't share that to the broader scope. And to that, I kind of want to just ask you if you guys have thought of different strategies to train an algorithm without having the data on place. So, for example, federated learning, and which is basically you just train the data without having the data, which I think it's something that could be really interesting in the fish community, because we have a lot of data set that many researchers have that could really benefit a central model.
Yeah, I think that's a common issue. Some of it's around privacy, some of it's around unique data sets that cost money to collect, and a lot of it in the scientific area seems to come down to published works and so on. It's a problem that the industry needs to get over somehow to make it be able to scale it. And I think that's it's a difficult question, a difficult issue. With Fishial, we have had a lot of photographers that get licensed photography that they're willing to contribute to Fishial, but they're not willing to have it distributed because they need to keep control of their libraries. So I think there's issues at every level when it comes to the scientific world, the recreational world, the you know, definitely from a photographer side. And that's why with the content management system that we put together, we supported, you know, a license on a individual image basis. And some of those contributions that go into Fishial are only to be used by, you know, Fishial data sets that can't be distributed because they don't want their photography out. So this is an issue across the board, and a difficult one to get around. Granted, I haven't looked at Google's open source in the last year or two, but early on we looked at, okay, there was ImageNet, and then there was Google Open Images, and out of millions of photos they had, there was about 5,000 images of fish, and none of them were it was either there was a fish or no fish. There was no scientific name. And so early on we started with those 5,000 images, and we basically hand drew polygons around them as to get it bootstrapped. And that was a painful experience, you know, of bootstrapping a segmentation model. And fish in this whole space, you know, the industry is going in different directions, but it's, you know, there's some work being done in the conservation space, but it's not a, you know, money maker slash prime area to have corporations invest a lot of money into. They do it out of, you know, contributing, you know, a back end to a corporation. But so there's not, you know, there's just, that's one of the reasons why we created this project was, okay, can we fill that gap? And after 3 years of working on this, and, you know, we put the infrastructure together, it's really then getting word out and embracing the scientific community is, hey, if you go build a research project and you publish your paper, how about contributing that data set back into a common pool? And so it could be reused. All that effort that was put in can be reused. And that's what we're attempting to do. And there's friction definitely in trying to get that done. It also, up to this point, we have not spent a lot of time trying to incorporate a bunch of data sets from that have been labeled out there, you know, at some point in time. Well, there's a lot of small projects. Okay, we're identifying 10 species and we have 5,000 photos, you know, in that space. We can import those and we can relabel them and so on, and that's all, you know, potential to do. We haven't put the manpower in there to really you know, try to swipe and sweep, you know, the 20 projects that have been done over the last 10 years and reuse their photos if they're available. You know, that's something we would like to do eventually. But right now we have a kind of a fire hose of photos that are coming into the project from numerous sources, and we're trying to handpick, you know, species lists and prioritize, you know, which ones we do, and at the same time try to also kick off, you know, more work in the reef area, you know, reef fish and so on. I think we have at least the core recreational side, like recreational fishers side, and that's due to a lot of what Fish Angler has contributed to the project. But just to give you the sense there, Fish Angler, we as a app, there's about 3,000 species every year, unique species. There's millions of photographs that are taken and posted into Fish Angler, but they represent about 3,000 unique species. And our model today does, say 300, and maybe the next version comes out and does 400, 450 species. That's the most frequent photos that are taken, but there's still another 2,500 species that we don't do in this model. And so that's going to take several more years, but we also are trying to get in, other aspects of underwater, as well as, divers and reef. We have some contributions from overseas, like fish aquarium distributors that distribute, fish around the world that are contributing photos back into the project too. We have limited resources on number of people we can put on, because this is a nonprofit, but, we're looking for volunteers, and we're looking for organizations to contribute and grow this. We've taken a shot at putting that infrastructure in place for people to contribute. And really, the project at this point needs to build out the the volunteer side of the project. So anybody that's that that might be interested in contributing in the common good here, that's what we're all about.
Yeah, thank you, Tom. Well, we're over the 1 hour for the seminar, so let's if you are not on the list for the consortium and are interested, please contact us, and we need to continue this discussion. Yes, Tom, and maybe meet separately from these seminars, to find further ways to collaborate. But thank you so much for the interesting talk, and thank you everyone for joining today. Thanks.
Thank you, and please reach out. You can reach me at support@Fishial.AI or TWYE@Fishial.AI, and then certainly go through Katerina too. And I like to see as a consortium, everybody get together here and see if we can all pitch in and make the overall vision work. Thank you.